Turkey has taken a significant step in underwater defense and maritime robotics, with the first test of the DERINGÖZ Autonomous Underwater Vehicle, a next-generation platform designed to strengthen the country's underwater situational awareness, reconnaissance, and deep-sea operational capabilities. It combines advanced hydrodynamics, long-endurance propulsion, AI-assisted autonomy, and modular mission payloads. The DERINGÖZ 100M600 program marks the maturity of this effort, based on previous platforms tested by Turkish defense companies. The new model is designed to operate at greater depths, with enhanced stealth, precision navigation, and a higher degree of autonomy supported by onboard artificial intelligence. The DERINGÖZ 100M600 can operate at depths of up to 600 meters, giving it access to a wide range of underwater environments. With a single battery, its endurance is nominal, but with 2 additional batteries, its operating time can be significantly extended to 24 hours, according to the latest specification sheet. Maximum speed, 5.5 knots. Scanning speed, 3 knots. Its relatively high maneuverability, combined with its modular design, allows for customizable mission profiles depending on the task at hand, whether it's a fast transit or a methodical scan. DERINGÖZ supports wired, wireless, and acoustic communications. Specifically, the system can use Wi-Fi, Iridium, and acoustic modems for data exchange under various mission conditions. This 3-layer communication capability is crucial, a reliable acoustic link underwater. The wireless link can handle satellite-level data. The system uses a modular architecture, meaning its payload can be reconfigured based on mission requirements. The standard payload includes a camera for optical imaging, a side-scan sonar for detailed seafloor imaging, a multi-beam echo resonator, synthetic aperture sonar, and obstacle avoidance sonar for advanced mapping and situational awareness. The 100M600 variant features a streamlined, low-drag hull optimized for silent movement and a minimal acoustic signature, a key feature for covert reconnaissance. Engineers working on the project note that the vehicle's geometry was refined using extensive computational fluid dynamics simulations and pressure chamber testing to withstand the extreme compression experienced at depths approaching several hundred meters. Propulsion is delivered through a lone noise electric drive, coupled with a high-capacity battery and an optional air-independent power module for extended endurance. While official figures remain classified, defense analysts estimate that the system can operate for tens of hours without surfacing, enabling it to conduct long-range patrols or detailed seabed mapping missions. The 100M600 also features a modular battery bay, allowing for mission-specific power configurations. This modularity provides logistical flexibility, allowing operators to tailor endurance for short-range, fast-moving reconnaissance operations or longer, stealthy missions requiring slow, measured movements. One of the DERINGÖZ 100M600 standout features is its advanced autonomy suite, which utilizes artificial intelligence and machine learning models trained on large datasets of underwater terrain, obstacle profiles, and acoustic patterns. Using a hybrid navigation system combining inertial navigation, Doppler velocity logs, sonar mapping, and surface GPS updates, the AUV can maintain high accuracy even without a continuous communications connection. In contested environments where GPS or acoustic channels may be disrupted, the vehicle's inertial estimation algorithms and AI enable it to complete missions with minimal external input. As naval competition under the sea intensifies, various countries are accelerating the development of more advanced unmanned underwater systems. These vehicles support a wide range of missions: intelligence gathering, mine countermeasures, infrastructure protection, anti-submarine surveillance, and oceanographic mapping. Turkey, already known for its rapid advancements in unmanned air and surface systems, is now channeling similar energy into the underwater realm.